Hello, class of Sandra Cisternos. That's how you pronounce it, right? I'm sure that's how you pronounce it. This is yours truly, Gabriel Ramirez, back at it again with a YouTube video. This is embarrassing. Okay, so today I made an 8-1 factors and greatest common factor slide. I made this early so I can give some of y'all a few, not pointers, but you can just copy out. No, don't copy out from my example. Don't copy. Just use my video, I guess, as a guideline. And if you don't know what to do, I made this as simple as possible. I didn't show my face. I don't have any editing program. This is just my MacBook and me and my phone. You'll see that soon enough. Okay, so let's get started. 8-1 factors and greatest common factors by Gabriel Ramirez. Well, I said that already. Okay, introduction. In this lesson, we will cover up on the basics of finding the factors, prime factors, greatest common factors, GCF, which I will be referring it from now on, and greatest common factors of monomials. These skills build a proper foundation for further algebraic concepts and skills. Things like 8-2 and so on and so forth. Okay. Finding the factors of numbers. This is the really basic skill. I just decided to put it here just in case y'all forgot this. So factoring is used to find all the numbers that are used to multiply to get the product of x. For example, the factors of 12 are 1, 2, 3, 4, 6, and 12. I found this. As shown, these factors can be multiplied by another factor to get the product of 12. So, as shown in this beautifully displayed picture, 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. Like show here. Wow! Hopefully you knew this. That's why I put wow. Writing prime factorization. Okay. This is a skill that is displayed in this lesson. Prime factorization simply all the factors of a number that are prime. A prime number is a number that only has two factors in total, 1 and itself. For example, the number 5 is a prime number. The factors of 5 are 1 and 5. Okay, so if you didn't understand that, then just look at these two methods of prime factorization. So the first method is a factor tree, which is the simplest, or not the simplest, just it's a factor tree. Okay, so in order to use this, it kind of looks like a tree if you go down. A Christmas tree kind of looks like it. So you put the original number on top, and you slowly build it down. So by the factors, so you would do 6 times 10 is 60. Now 2 times 3 is 6, and 5 times 2 is 10. So you get the point. And and you keep doing that until you only get prime numbers. So 2 is a prime number, 3 is a prime number, 5 is a prime number, and 2 is a prime number too. Okay, boom! Ladder diagram. This is the second method, and hopefully this looks familiar to you guys. Just hopefully. So in this method, you just keep dividing, like I say, by a prime number. Now, the number that goes here has to be a prime number, or else the method just won't work. Okay, that's like the most important note to put here. This has to be a prime number: 2, 3, 5, 7, 11, things along those lines. And so you keep dividing, or however you want to call it, by a prime number until you get a number that cannot be divided anymore. Okay, so 2, 2, 2, and 3 are prime factors, you would say. Okay, and slide number 3. Finding the greatest common factor of numbers. Okay, so factors that are shared by 2 or more whole numbers are called common factors. The greatest of these factors are called the greatest common factor. Whoa! Simple. Okay, put simply, the GCF of 2 numbers are the greatest factors that can be used to multiply into the original numbers. Grammar. Okay. There are 2 methods of finding the greatest common factors. So, hopefully this method is simple enough. It's probably it's the easiest to understand. So you list all the factors, and look at these circles. They're not placed right. Oh well. And you list all the factors of the 2 numbers, and you circle the greatest common factor. So in this case, the greatest common factor is 12, as shown here. And then the second method is to use prime factorization, as shown in the last slide, which you have to make the ladders and everything. So once you make the ladders, you can write it down. The prime factorization of 18 is 2 times 3 times 3. The prime factorization is 27 is 3 times 3 times 3. So you combine these in order to find the greatest common factor. You combine the two greatest common factors and you multiply them. So the GCF of 18 and 27 is 9. Hopefully you understand this. Just get a good look if you want to take notes or something. Or you can just pause the video. Okay, next slide. Bam. Finding the GCF of monomials. Yeah. One can also find the greatest common factor of a pair of monomials. The easiest method to solve is by using prime factorization. So, as you noted, there's nothing on this slide. And you will see very soon. Just not now, though. Just keep waiting. Not now. Not yet. Not yet. And wait a moment. Nope, not yet, not yet. Now! Hello. Hi. This is a real-life tutorial on how to find the greatest common factor. It's not focusing. On how to find the greatest common factor in monomials. So, you've seen it in the slides, but I decided to do this because it's a better explanation. Okay, so in order to find the greatest common factor of monomials, which means like that's a monomial, that's a monomial. I'm pretty sure anyway. So I find that the easiest method to find the greatest common factor with this is to do the ladder method, which was displayed to you in an earlier slide, but I'll just show it again. Okay, so first what I would do is I would recopy it, squared, and then just do the ladder method. You do this, and so on this side it would be the values that you have left, and on this side of the little line you would put a prime factor, which would mean prime numbers as in 3, 5, 7, 11, and so on. You get the gist. So you would put prime numbers on this side and the values that that you still have on this side, and you keep going until you have 0 or 1, or just you can't divide anymore. So yeah, I said dividing because it's the way that I think of it. So the first value I would put here is 3 because it's a prime factor. Oh my god, there's so many dots now. What have I done? So now there's 3, and I divide it by 3, and it takes away. So now I have x squared, and I do this little ladder thing again. So kind of looks like a ladder, but you get the point. Okay, so then you have to divide this by x. Takes away this first exponent. Then you just rewrite it as x. Or x1. It means the same thing if you just put x. In order to divide this, you can put x one more time. Okay? So let's move this for a minute. Now, well, I moved it, but now what you can do is, since it's already divided and you can't divide by anymore because this would just be 0, I circle this, and this is the prime factorization. So that would mean 3x squared is equal to 3 times x times x. So this is the prime factorization of 3x squared. So now let's do x squared. And now we continue factoring with 6x squared. And so we'd use the same method. I use the same method actually, the ladder method, and I do the same thing. So originally what you would do is you would divide this by 6. But the only problem is that you're supposed to divide it by a prime number, and 6 is not a prime number. The factors of 6 are 1, oh, whoa, that was a really large sound. 1, 2, 3, and 6. Those are the factors. But 6 is not a prime factor. The only prime factor that you can divide 6 by is 3. There you go. And you divide 6 by 6x squared divided by 3. And that is 2x squared. There you go. And 2 is a prime number, so you can divide this by 2. And you leave you with x squared. And so on. And and so on. There you go. So now the prime factorization of 6x squared is 3 times 2 times x and times x. And it makes sense because 3 times 2 is 6, 3 times 2 is 6, and x times x is x squared. It makes total sense, right? I think. Okay, so now I just rewrote both prime factorizations aligned, and as shown, these are all the prime factors like I just said. And so the greatest common factor here would be 3, because 3 is on both things, and 3 is the greatest common factor. So the GCF, or greatest common factor, of 3x squared and 6x squared is 3. Boom. You just got taught some math. Thank you, and subscribe. Hopefully you enjoy this new video. It's 8:34 p.m. Nice. Hopefully you enjoyed this video. This is like a tips and tricks if you guys want to learn. Not learn, but like, this is just a guideline for you guys to share. I embarrassed myself. Okay. Goodbye. Hit that subscribe button.